Alrighty guys, we are going to go ahead and start reading lesson 2 about the Earth's moon. So the key concepts that we are interested here would be, how does the moon move around Earth? So that's going to be today. And why does the moon's appearance change? That's going to be on moon phases, and that's going to be next time, okay? So I have already gone ahead and organized our colors. So if you would highlight seeing the moon in green and the moon's formation in purple, and then scroll down and the moon's motion in blue. And you can go ahead and draw a line after that, because that's as far as we are going today. Phases of the moon we'll pick up next time. Okay, so draw your line there. Blue, purple, green. Okay, so let's go over to our notebook and let's mark those exact same things. So green, purple, and blue. Okay, and you can draw your line there right before phases of the moon, because that's where we're going to end today. Okay, so let's get ourselves organized. So in this first section on seeing the moon, we're going to look and read to learn about why you can see the moon. Okay, all right. Why does the moon shine? Why does its shape seem to change? The moon does not give off light. Unlike the sun, the moon is a solid object. You see the moon because it reflects light from the sun. All right, so let's go ahead and highlight that. Data from the moon's mass, size, and distance from Earth are shown below. Alrighty, so it has 1.2% of Earth's mass. The diameter is about a quarter of Earth's diameter. The average distance from Earth, 364 kilometers. Time for one rotation, so one time on its axis, it takes 27.3 days. And one time around us, so one revolution around Earth, also takes 27.3 days. That's going to come into play a little bit later, okay? So let's go ahead and answer that first question on our science notebook. Explain why you see the moon, all right? So light from the sun reflects off the moon and into a person's eyes. All right, so we see it, not because it makes its own light, because we know that the moon does not make its own light. It is simply reflecting the light from the sun, and then that reflected light goes into our eyes, okay? All right, so then this next section on the Earth's formation, we're going to be looking at a particular theory, the collision theory, and the steps, the sequence of the events of that, okay? All right, so let's go back to our reading essential, the moon's formation. The most widely accepted idea about how the Earth formed is the giant impact hypothesis. The giant impact hypothesis states that shortly after Earth formed, an object about the size of the planet Mars crashed into Earth. The impact caused a ring of vaporized rock to form around Earth. Eventually, the material in the ring cooled and clumped together and formed the moon. Once again, that is a scientific idea about the formation of the moon. And this is a hypothesis, right? Because nobody knows for sure. All right, so then we're going to look at the moon's surface. Early in Moon's history, several features formed on its surface. The main features on the Moon are craters, maria, and highlands. So we've got craters. The Moon's craters formed when objects from space, such as large rocks, crashed into the Moon. Light-colored streaks called rays run outward from some craters. Most of the Moon's craters formed about 3.5 billion years ago. This was long before dinosaurs lived on Earth. Earth also was hit by many large objects during this time. Wind, liquid water, and plate tectonics erased these craters on Earth. The Moon has no atmosphere, no liquid water, and no plate tectonics. So plate tectonics, you're going to learn about that in 7th grade. So that is under the surface of the Earth. That's what causes earthquakes, okay? Without these forces, Moon's craters formed billions of years ago and have not changed much. So I see a vocab word here, so we are going to go ahead and switch to yellow. So maria, the large, dark, flat areas on the Moon are called maria. The maria formed long after most impacts on the Moon's surface had ended. Maria formed when lava flowed through the Moon's crust and hardened. The hardened lava covered many portions of the Moon's surfaces, including many of its craters and features. So we had the impact of space rocks and whatnot creating these craters, and then lava flowing up from the center, filled out and hardened. And so that's that black shiny look that you see when you look up at the Moon. Okay, so then we have the highlands. So I'm going to switch out here. So the highlands are the light-colored areas on the Moon are the highlands. Highlands were not covered by the lava that formed the maria because they were too high for the lava to reach. Highlands are older than the maria and are covered with craters. So those would be like some hills, some mountain types of things, and they're still going to get bombarded by those space rocks, so they're still going to have craters on them, but we're tall enough, high enough not to be filled in those craters when the lava flowed up, okay? All right, I see that I'm at the Moon's motion, so we need to switch over to our notebook. All right, so we're going to sequence the events in the Moon's formation. So it's a collision between a Mars-sized object. It's not a collision with Mars, but a Mars-sized object and Earth. Okay. So a collision between a Mars-sized object and Earth occurred. Blank was ejected into space and a ring formed blank. So what happened? We had vaporized rock was ejected into space and a ring formed around Earth. Okay, we'll just leave that capitalized. Okay, so get that filled in. So material in the ring, it cooled and clumped together. Oops, let's spell that right, huh? And formed the moon. All right, so make sure you stop this video at any point when you need to fill in faster than I'm typing, right? Okay, so now we're going to take a look at moon's surface. So the craters, what are they? Let's go ahead and make this immediately bigger. The craters are depressions that formed when objects crashed into the moon. Okay, so that would be like if you have your sand or whatnot, and you've got like a marble, then you drop it into the sand, it's going to give like a little divot. That's exactly what happened. So depressions that formed when objects crashed into the moon. Okay, so then let's take a look at the Maria. So the Maria are large, dark, flat areas on the moon. Okay, and so they formed from lava flows. Okay. All right, so let's get that in that little space there. So when deep down in the earth or in the moon, there was lava that flowed up and filled in these craters. Okay, so we're going to add that in there, that it filled in the craters. Okay, so filling in the craters. There we go. That's grammatically better. All right. So then we have one last. That's going to be our highland. Okay, so let's get that positioned there. All right, so our highland. What is that about? Those are the light colored areas that are higher than Maria and covered with craters. Okay, so they're going to be high enough up there so when that lava came through, then they did not get filled in. So they're going to be like hills, mountains, types of things. They're higher than the Maria, and they are covered with craters. They were, sorry about that, guys, with it flipping all over the place. They were not filled in with lava. Okay, and that's because they were too high. Okay. Here we go. There, I can see that. That is not spelled right. All right, so the high-colored areas that are higher than Maria and covered with craters, they are not filled in with lava. Okay. All right, so that takes care of the surface of the moon, and we have one section left on moon's motion to fill in. So let's go back to our notebook, our reading essentials. There we go. So Earth's motion. As Earth revolves around the sun, the moon revolves around Earth. Okay, so let's go ahead and mark that. As Earth revolves around the sun, the moon revolves around Earth. The pull of Earth's gravity causes the moon to move in an orbit around sun. Move in an orbit around Earth. Sorry about that. Let's back that up. The pull of Earth's gravity causes the moon to move in an orbit around Earth. Recall from lesson 1 that if the pull of sun's gravity ended, Earth would fly in a straight line into space. The same would be true for the moon if the pull of Earth's gravity ended. The moon makes one revolution around Earth every 27.3 days. Like Earth, the moon also rotates as it revolves. One complete rotation of the moon also takes 27.3 days. Notice that this is the same amount of time it takes the moon to make one complete revolution around Earth. And that is called synchronous rotation. Okay, synchronous. It's all in sync. Okay, the same side, let's switch this, get a new color. The same side of the moon always faces Earth because the moon takes the same amount of time to orbit Earth and make one rotation. This side of the moon that faces the Earth is called the near side. The side of the moon that cannot be seen from Earth is the far side. So let's change and mark that. The side of the moon that cannot be seen from Earth is the far side of the moon. Okay? All right. So then that ends that. Let's go ahead and fill in this last part of our notebook. All right. So the amount of time for the revolution is 27.3 days. And then also, for rotation is 27.3 days. All right? Describe the motion of the revolution. And so this is the same motion as us around the sun, okay? The moon around us. Okay, so the moon revolves. And then that's also, we're going to put in slash orbits Earth. Okay, because remember, our definition for a revolution is one object going, a smaller object going around a larger object in space. Well, that smaller object is the moon going around a larger object, us. Okay? All right, so let's take a look at rotation. What that does is the same as the rotation here for Earth. Okay, so the moon spins on its axis, just like us. Okay? All right. So I want us to add in here that from Earth, we always see the near side of the moon, never the far side. Okay, that's why I always see the same side of the moon, and that is because of synchronous rotation. Okay, synchronous rotation is the reason why we only see the same side of the moon, because it is rotating one time on its axis and making one revolution around Earth at the exact same rate, synchronized. So that's why we only see one side of the moon. Okay, so explain why the same side of the moon always faces Earth. Okay, we already talked about that, but let's go ahead and put that in here anyway. Okay, so the moon takes the same amount of time to orbit Earth as it does to make one rotation on its axis. Okay, let's get that in there. And just get that all there for you. And so this is synchronous rotation. Okay, synchronous rotation. Alrighty, so that wraps up this section. You are able now on your study guide to do the next section on the moon. Oh, I don't have the study guide in my Notability. But on your study guide, if you get that pulled up, the second section on the first page called The Moon, you can fill that out now. Okay? Alrighty, reach out if you need anything, and I hope to see you soon.